this question is about a different sort of graph question. We've seen velocity time speed time acceleration time graphs before. This one is a different sort of graph question where it's kinetic energy displacement graph. So the only really tricky bit is, I think, being sort of understanding why it's not a straight line. So the kinetic energy with displacement at zero, the displacement at this point, the kinetic energy is at a maximum because it's going fastest here. So if you imagine the pendulum swinging, it's going fastest in the middle. So you'd start it off at one point. The components of weight and therefore tension. So the tension makes it accelerate into the middle. At the middle, the tension is acting straight up. So there's no component in the horizontal direction. So the speed it's gained as it goes to the middle allows it to continue through the middle. And then as it moves upwards, the component of tension increases. And as you move from the middle, work is being done against the component of tension, which causes it to slow down until it stops. So it stops. So it's at a minimum. So maximum displacement, positive displacement, it's at zero. Minimum negative displacement, it's at zero. In the center, it's a maximum. So that's when the displacement is at zero. The kinetic energy is the maximum. So that is graphs A or D. Then why is it not linear? Well, the simple answer, it's not linear. A more difficult answer is, well, you can consider it in terms of forces. You've got these components varying. These components will be varying as trig functions from the geometry of the situation. In terms of looking at the equations, in terms of how is displacement linked to velocity, the link between, this is SHM, so the link between displacement and speed. So the energy is a half mv squared. So that would be this v half mv squared. So that would be omega squared multiplied by a squared minus x squared. But the x squared is it depends on a cosine function. So you've got this level of complexity where it's clearly not a straight line, but to fully prove and demonstrate the equation of that line would be a lot more demanding and probably not really something you have to do at A level. So it's got to be A or D, and it's non-linear, so it's got to be D.